Hello, today I'm going to discuss the lesson 2-2 notes, and this lesson involves the slopes of both parallel lines and perpendicular lines. If you recall from the previous lesson 2-1, we learned that the slope formula is just the difference of y's over the difference of x's. So y2 minus y1 divided by x2 minus x1. And this is really just the long way of saying rise divided by run. Rise over run. Now if you ever look at lines, if you had two lines like this, they're going to have exactly the same slope. And these are parallel lines. So whenever you see parallel lines, they have exactly the same slope. But the trickier one is perpendicular lines. If you have two lines that are exactly perpendicular to each other, their slopes are not going to be the same. In fact, they're going to be different in two different ways. The signs are going to be different. So it's going to be the opposite sign, and then the slope is going to be the reciprocal of the original. So we say the slopes of perpendicular lines are opposite reciprocals. And opposite means change the sign, and then reciprocal means flip the fraction. Okay, so that's what opposite reciprocal means. And we'll go over some examples very soon. So for example, if we have a slope of 2/5, 2 over 5, the slope of the parallel line is going to be exactly the same. It's also going to be 2/5. That one's very easy. The slope of the perpendicular line, though, you have to change the sign and flip the fraction. So if you change the sign, now you have a negative, flip the fraction, you get 5 over 2 instead of 2 over 5. So the perpendicular slope will be negative 5/2. Now let's look at two different examples, A and B. They each have a line graphed. So what you're going to want to do is calculate the slope. The easiest way to do this is really just see how far up you're going. From here, I'm going up 1, 2. So that's a rise equals 2. And then run equals, let's see how much we're running. We're running, how far did we run? 1, 2, 3. We ran 3 after we rose 2. So rise 1, 2, run 1, 2, 3. So this is really all you got to do to calculate your slope if you have it graphed for you. So your slope was 2/3, or you could have done the y2 minus y1, which is 2 minus 0. That also gives you 2. And then x2 minus x1, which is 0 minus a negative 3, or 0 plus 3. Anyway, if the original slope was 2/3, that means the parallel slope to that would also be 2/3. It's going to be exactly the same slope. They would be just side by side. But the perpendicular one, you're going to have to change the sign. So instead of positive, it's going to be negative. This is the symbol for perpendicular, by the way. The slope of the perpendicular will be negative. Instead of 2/3, you flip it, and the reciprocal gives you 3/2. So we went from 2/3 to negative 3/2 for the perpendicular line. Let's do another one. This one is your point, and this was at negative 4, 0, and this was at negative 0, negative 2. 0, negative 2 was that one. Okay, and what would be your rise over run? It might be helpful to just do y2 minus y1 over x2 minus x1, just to be on the safe side. Because otherwise, if you just say this is a difference of 2 and this is a difference of 4, you may not get it right because you might get the sign wrong. So y2, I'm going to call that y2. So that's going to be negative 2 minus a 0. x2 is 0 minus a negative 4. So that gives me negative 2 minus 0 is still negative 2. 0 minus a negative 4 is the same as 0 plus 4. So we got negative 2/4, which is really equal to negative 1/2. And that is my reduced fraction that represents my slope. The slope of the parallel line will be exactly the same, negative 1/2. And the slope of the perpendicular line, we're going to change the sign so it's not negative anymore, it's going to be positive. We don't really need to write the positive sign down. It's going to be positive, the reciprocal of 1/2 is just 2. So we don't have to say 2 over 1, we can just say the slope is 2. That implies 2 over 1 though. Okay, let's go on to the next section. Find the slope of a line between 2 points. Then decide what the slope of the parallel line is and the perpendicular line. So it's going to be about the same, but we don't have the graph this time. So again, I'm going to say x1, y1, x2, y2. Determine your slope. Your slope is going to be y2, okay, slope is equal to y2 minus y1 over x2 minus x1, which is equal to 2 minus a negative 2 over negative 1 minus 3. Change your signs because you had a double negative. 2 plus 2 is 4. Negative 1 minus 3 is negative 4. So 4 over negative 4 is just a negative 1. And that is your slope. Your parallel slope will be exactly the same. And what is the opposite reciprocal of negative 1? Well, the opposite means it's going to be positive, and the reciprocal of 1 is still 1. So we went from a slope of negative 1 to the perpendicular slope of positive 1. Okay, let's try this letter B example. The line going through here, if this is x1, y1, x2, y2, your slope is going to be y2 minus y1, so that's 10 minus 4, over x2 minus x1, which is 5 minus 2. So your slope is going to be equal to 6 over 3, which is just the same thing as saying 2. So my slope is 2. My parallel slope will also be 2. And the opposite reciprocal of that is negative 1 over 2, or negative 1/2. Okay, so those are some examples of just finding slopes, and then the parallel and perpendicular slopes. It's about the same thing every time. Now let's try to determine whether these two segments are going to be parallel, perpendicular, or neither. The first segment of interest is xy. So x and y are my 2 points, and I'm going to group those together, and then a, b will be my next segment of interest. So the slope of xy, of segment xy, I'm going to call this my x1, y1, x2, y2. So I'm going to say the difference of y's, which is 2 minus 1 over negative 4 minus 3. And that will give me 1 over negative 7. So my slope of xy, which I have a blank for, is negative 1/7. Okay, it's usually we'll write the negative out in front instead of being attached to one of those numbers. It's the same thing, but it's custom to write it out in front. Now, what is the slope of segment AB? We'll do the same thing. x1, y1, x2, y2. So the difference of the y's is 3 minus 10 over, and then the difference of x's is 3 minus 4. So you have negative 7 over negative 1. Oops, that wasn't the right number. Negative 7 over negative 1. And negative 7 divided by negative 1, they're both negative, so that just becomes 7. Now, we can write that as the slope of AB. Negative 1 and negative 1/7 and positive 7. They're obviously not the same, but are they perpendicular? Let's see. Are they opposite signs? Yes. One's negative, one's positive. Is 1/7, the reciprocal of 1/7 equal to 7? Yes again. So that means they must be perpendicular to each other. And you could write that with the perpendicular sign instead. Either way you want to write it. So it just happened that they're exactly opposite reciprocals. So they are perpendicular. Moving on to the next page. Let's do that again. For, again, points x, y, and a, b. What is the slope of x, y? We're going to take your difference of y's, which is -3 minus a -1. I'm just going to go ahead and change that double negative to a positive. And then the difference of x's, which is 4 minus a -2. Again, I'm going to change that to double positives instead of double negatives. So what does that become? -3 plus 1 is -2. 4 plus 2 is 6. And that reduces to -1/3. So the slope of xy is -1/3. What about the slope between AB? Segment AB has a slope of, the difference of y's is -2 minus 6 and 3 minus 1. So that gives you -8 over 2, which is -4. Well, -1/3 and -4, they're obviously not the same, so they're not parallel. Are they opposite reciprocals? No, they're not opposite, and they're also not reciprocals, so they're neither. So this is neither parallel nor perpendicular. So you can say not parallel or perpendicular, or you can just say neither. It's neither parallel nor perpendicular. This really probably should be a nor. Not parallel nor, well, no, actually. Neither parallel nor perpendicular. So yeah, not parallel or perpendicular is the right way, sorry. Okay, so graph the line that satisfies these conditions. You may need a straight edge for some of these, so I'm going to get out my straight edge right now and keep it handy for when I need it. There's going to be a line that passes through this point x. X is at -2, 4, so I'm going to plot that. 1, 2, 1, 2, 3, 4. And I don't really know where to label it just yet, so I'm going to hold off on labeling that x because I don't want it to be in the way. And then I need it to be parallel to a line containing these 2 points. 3, 5, 1, 2, 3, 3, 5, and also -1, +1. Okay, so here's my -1, +1, and 3, 5. It's going to go through there. That is my line. So really, what you want to do is calculate the slope. So this is, I already know x is here. I know that the parallel line is going to go right beside that, so I'm free to label x now. And if you really want, you can label these. It's probably helpful if you just say that's -1, +1, and then this was 3, 5. What you want to do is calculate the slope. So what is the slope between 3, 5 and -1, 1? Well, the difference of y's was 5 minus 1. The difference of x's was 3 minus a -1, which is equal to 4 over 4. Sorry, did I do that wrong? Oh, 5 minus 1. Actually, the key was wrong. 4 over 4. Yeah, okay, so 4 over 4 is equal to 1. So that gives you a rise over run of just 4 over 4, which is the same as having a slope of 1. So that's all we got to do is get a slope of 1. Rise 1, run 1. Rise 1, run 1. And if you do that more than once, it's a little easier to see. I'm going to go ahead and use a different color this time, just so it's a little easier to distinguish between these two graphs. And okay, so if I had spread out my points better, this would have probably looked a little better. If you make your 2 points too close together, then the line may not be exactly the direction you want to go, which is why these don't look entirely parallel. They're pretty close, but not perfect. I should have spread out more with my points, and then my straight edge would have given me a better slope. Okay, this next one's a little bit different. I have a slope of -2. So really, if you want to think of that as being a fraction, that's fine. It's got a rise over run of -2 over 1. And it passes through point -1, 4. -1, 1, 2, 3, 4. So it passes through this point, and it's got a slope of -2, 1. So I'm going to do a rise of -2. So I'm going to rise in the negative direction. So that means I'm going to go down 1, 2, and I'm going to run 1 in the positive direction. You see how now I have a negative slope. It's falling as you go from left to right. I'm going to do that again. Go down 2 and over 1. And you could even do it again, 1, 2, 1. It's up to you how many times you want to do it. But the more spread out the lines are, more spread out the points are, the better you will have for accuracy. So this is my point. This is my line connecting those points. That one was a little easier because we didn't have to do as much work. Now, this one's going to be perpendicular. For example C, we need to pass through point B, which is at -3, 2. So that's point B. And it needs to be perpendicular to this line at 2, -1, and -2, 7. Let me make sure I counted that right. 1, 2, 3, 4. Okay, so that's -2, 7. So it needs to be perpendicular to that line that just goes through those 2 points we just drew. And this is point B. It's going to go roughly there, so I'm going to put the B labeled there, out of the way. It helps if you know what the slope of that line is, that you need to be parallel. So what is the slope of that line we just drew? We were going from, this is x1, y1, x2, y2. So my slope is going to be 7 minus a -1 over -2 minus another 2. So that is equal to 8 over -4, which is equal to -2. And the slope of the perpendicular going through point B, the perpendicular slope would be the opposite sign, so positive, and then the reciprocal of 2 is 1/2. This is the slope we need to use for this new line. So it's going to go rise over run of 1 over 2. So that's 1, rise 1, run 2. Rise 1, run 2. I can do it one more time. Rise 1, run 2. And I'll draw this one with red pen so it's a little more clear that I have these 2 different lines. And there you go. There's your perpendicular going through point B, and it does look like it's perpendicular, so that works out well. So just remember, rise over run is the difference of y's over difference of x's, and your reciprocals, opposite reciprocal is how you find your slope of your perpendicular lines, but parallel lines have exactly the same slope.